Hey, sixth graders, we are going to continue in our lesson talking about states of matter and changes of states. So the states of matter is going to be a little bit of a review what you just took notes on, but we're going to talk about it real quick anyways. So states of matter, all matter is made up of tiny particles. These particles attract each other, and the greater the attraction, the closer the particles get. So these particles are constantly in motion and bumping into each other. The temperature of the substance is directly related to the speed at which the particles move. So if you watched that video or you did that simulation, you saw that as the temperature got hotter, the particles changed. All right, so some of the states of matter that we have been working with are solids, liquids, and gases. A solid, it keeps its shape and its volume. A liquid takes on the shape of its container, or it keeps the same volume in any container, and it can flow. Gases take the shape and volume of its container, and they can flow through a room or through different spaces, for example. So again, the solids are the particles of a substance in a solid state vibrate in place, but the vibration isn't great enough to overcome the attraction between the particles and causes them to separate. As a result, the forces between the particles cause them to lock together, which causes them to be a solid. The particles of the substance in a liquid move faster when the substance is in a liquid state. So as a result, the particles in the liquid can overcome some of the attraction between them. And the particles of a substance move fastest when the substance is in a gaseous state. So fast that they are able to overcome the attraction between them and separate from each other entirely. So this is an example of what those would look like. So in a solid state, you see that the particles are very close together and then they're moving further apart. And then in the gaseous state, they can move and bounce around a lot more freely. All right, now we are going to move into the states of matter, which is not something you have read about yet. So you should be prepared to read about this, and then you are going to take some notes on it in your Cornell guided notes. So what happens when matter changes states? Imagine you are eating ice cream on a hot summer day, and it can be kind of messy. The faster you lick it, the ice cream melts and it drips down your hand. As the ice cream melts, it goes through a change of state. The three familiar changes of states that we just talked about and you read about are solid, liquids, and gas. A change of state is the change of a substance from one physical form of matter to another. When the substance undergoes a physical change, it does not change its identity, just its appearance. It can be gained and lost. To change a substance from one state to another, the energy must be added or removed. So when a substance gains or loses its energy, its temperature changes or its state changes. These two changes don't happen at the same time. The temperature remains constant until the change of state is complete. Example of this in one of our work pages down below. So we'll talk more about that when we get there. So particle motion then changes. So all matter is made up of tiny particles that are in constant motion. During the change of state, the motion of the particles change. So particles can break away from each other and gain more freedom to move. This happens when a solid changes to a liquid or a liquid changes to a solid. Particles can also attract each other more strongly and have less freedom to move. This happens when a gas changes to a liquid or a liquid changes to a solid. Energy is also conserved. So during the change of state, a substance must gain energy from the environment or lose energy to the environment, but the total amount of energy is going to be conserved. So an example we can think of is the water cycle. So when we think about the water cycle, the water is converted from a liquid water to water vapor, then to solid snow, and then it's converted back to a liquid. Each change of state represents a transfer of energy into or out of the water cycle from the surrounding environment, but the energy is never created or destroyed. How do solids and liquids change state? The particles in a liquid can slide past each other, but the particles in a solid can only move enough to vibrate. So removing energy from a liquid can cause it to change to a solid as the particles stop sliding past each other. Adding energy to a solid can cause it to change to a liquid as particles begin sliding past each other. So some ways this can happen is the change of state, which is from a liquid to a solid, is called freezing. When a liquid is cooled, its particles have less energy, they slow down, and they lock into a fixed arrangement of a solid. The temperature at which a liquid substance changes into a solid is its liquid's freezing point. When a solid is warmed, its particles gain energy and speed up, and then the attraction between them starts to decrease, and eventually they begin to slide past one another again. The change of state from the solid to a liquid is called melting, and the temperature at which a substance changes from the solid to the liquid is called its melting point. Think about a melting snowman. So the energy from the sun is added to the solid snow, and then the particles in the snow begin to move faster. When the temperature of the snow reaches 0 degrees Celsius, the added energy of the particles will overcome some of the attraction that hold the particles in place. The snow starts to melt. And as the sun continues to shine on the snowman, even more attractions are broken. Eventually, all the snow will turn to liquid water, and you won't have a snowman anymore. All right, so how do liquids and gases change states? Particles in a gas have a great deal of energy, so removing enough energy from a gas can cause a gas to change to a liquid or a solid. Adding enough energy to a liquid or solid causes it to change into a gas. The process by which a liquid or a solid changes to gas is called evaporation. So as a liquid is warmed, its particles gain energy, and some of the particles gain enough energy that they escape from the surface of the liquid and become a gas. This process is called evaporation. A rapid change from a liquid to a gas or a vapor is called boiling. This change takes place through a liquid, not just at the surface. So the specific temperature at which this occurs is called the boiling point. As a gas is cooled, its particles lose energy, so the attraction between the particles overcome the speed of their motion, and a liquid forms. So this change of state from a gas to a liquid is called condensation. Some examples that you might think of are when you boil water, right? When you put your water in a cup and you see that on the outsides you have condensation. Lastly, how do solids and gases change state? So under the right conditions, some solids and gases can change states without becoming a liquid. So the substance must gain or lose a great deal of energy for this to occur. This change from a solid state directly into a gas state is called sublimation, and deposition is when the change of a state from a gas directly to a solid occurs. What happens to matter when a change of state occurs? When matter changes from one state to another, it remains the same kind of matter. Its physical state changes, but its chemical identity does not. So an example would be an ice cube and the puddle it forms when it melts are both made up of water. During this change of state, the energy of the particles and their movement and the distance between them changes. Mass is conserved. The mass of a substance does not change when its state changes. Each state contains the same amount of matter. Think about particles of water in a closed container. They don't disappear even if the particles escape from the liquid and they stay the same in the container as a gas. But because the number of particles in the container stays the same, the matter is conserved.